Hello and welcome to this critical analysis. Exactly 14 hours ago, on July 3, 2026, NASA's Deep Space Network logged an unprecedented cosmic event that changed everything we know about our solar system. An interstellar object known as 3I Atlas just did the impossible. It stopped. It did not collide with anything, nor did it use a gravitational slingshot to swing around a planet. Instead, it actively balanced itself directly on the Earth's Lagrange 2-point. The telemetry recorded at exactly 1842 UTC is entirely unambiguous, and what it shows has absolutely no precedent in the history of modern astronomy. Picture a rogue comet from deep space hurtling toward our inner solar system at tremendous velocities. Then, exactly 1.5 million kilometers from Earth, it simply bleeds off its momentum and slips into a perfect, stable halo orbit. Precision that tight requires control, and control requires intention. In all the history of theoretical physics and celestial mechanics, a purely natural ballistic object has never been observed executing a maneuver like this. A comet does not just decide to stop at a gravitational parking spot. To put this in perspective, the L2 point is essentially a cosmic balancing act. It is a specific region in the vacuum of space where the gravitational forces of the Sun and the Earth perfectly equal the centripetal force required for a small object to move with them. It is highly unstable for natural bodies. Think of it like trying to balance a pencil perfectly on its tip upon a spinning plate. To stay there, human-made satellites like the James Webb Space Telescope require continuous calculated thruster burns, which scientists call station-keeping maneuvers. Yet, 3I Atlas is currently sitting there maintaining a positional accuracy within a tiny fraction of a degree. The physics here is intriguing because there is no thermal outgassing, no visible propulsion system, and no tail acting as a natural thruster. The numbers are definitive. NASA's trajectory models predicted it would pass us by entirely, and the European Space Agency's Gaia spacecraft calculations agreed completely. But the models were mathematically wrong. When you examine the data, you are forced to question our fundamental assumptions. Everyone assumes 3I Atlas is a dead rock or a chunk of dirty ice, but the data suggests otherwise. When an object precisely navigates into one of the most mathematically complex, gravitationally delicate coordinates in our solar system, we have to ask a very uncomfortable question. Pause and realize what this means. If it is not a rock and it is not a comet, then what is currently hovering just beyond our moon's orbit, staring back at us? Even the most conservative astrophysicists at Harvard and MIT are currently re-evaluating every piece of telemetry we have ever gathered. When institutions at that level take emergency action, we need to pay very close attention. The implications are profound, and this physical impossibility is playing out in real time. But that is just the beginning of this mystery, and what comes next is even more shocking. To understand what we are dealing with, we have to look back at what exactly 3I Atlas is supposed to be. Discovered on August 14, 2025, it was initially classified as an interstellar comet, the third of its kind, following the famous discoveries of Oumuamua and Borisov. But from the moment it entered our solar system, it was a massive statistical outlier. The core differentiator was its albedo, meaning it reflected light at an efficiency that defied standard carbon or ice models. We are talking about a mass estimated at 33 billion tons, moving at a blistering 87.63 kilometers per second. It was supposed to be a fleeting visitor, a brief streak of light on our cosmic doorstep. But on April 4, 2026, the narrative completely fractured. The James Webb Space Telescope's near-infrared camera was the first to detect the deceleration as 3I Atlas crossed the orbit of Mars. Its velocity began to drop, not by a fraction of a percent due to solar wind or outgassing, but in a sustained mechanical braking maneuver. The numbers don't lie. The deceleration curve was perfectly smooth, reducing its speed by exactly 12.4 kilometers per second over a 48-hour window. This should not be possible because comets do not have brakes. In a vacuum, an object of that mass requires an immense directional expenditure of energy to alter its momentum so drastically. The kinetic energy equations simply do not balance out. When these numbers first appeared, scientists had to verify them twice. The scientific community immediately triggered observation protocols, and this is where the data becomes undeniable. NASA's Deep Space Network antenna detected the anomalous trajectory shift. The Gaia spacecraft independently verified the exact deceleration curve with its astrometric sensors, and the ALMA array in Chile cross-referenced the thermal emissions, yielding the exact same result. Three independent sources, using entirely different methodologies, arrived at the identical conclusion. Think of it like throwing a baseball perfectly straight, only for it to slow down midair and gently hover just before reaching the catcher's mitt. Now multiply that scenario by the cosmic scale of a 33 billion ton object. Consider the implications. There was no cometary coma, no jets of gas venting into space, and no thermal bloom to explain the loss of kinetic energy. The physics here breaks down completely. If we cling to the comet hypothesis, a natural body cannot bleed off that much momentum without an equal and opposite reaction visible in the infrared or ultraviolet spectrum. Yet the object remained thermally cold, hovering at a baseline of 34 Kelvin. To execute this maneuver naturally, 3I Atlas would need to expel roughly 15% of its total mass in a highly directed focused jet. But the data confirmed zero mass loss and zero outgassing. The object remained entirely intact while shedding velocity, as if it were interacting with a frictional medium that simply does not exist in the vacuum of space. The conventional explanation would be a miscalibration of our instruments, but what if our instruments are entirely accurate? Wait until you hear what happened next. First, the inexplicable deceleration happened, and then the trajectory altered entirely. It was no longer aiming for a solar perihelion, which is the closest point to the Sun that 99% of known comets target. It was aiming specifically for Earth's L2 Lagrange point instead. By April 7, 2026, the vector adjustments became micro-precise. At 48 hours to arrival, it executed a microscopic yaw correction, and at 24 hours, it performed another precise correction, perfectly aligning its path with the gravitational saddle point located 1.5 million kilometers behind Earth. Right now, it is completely stationary relative to our planet. The positional lock is maintained within 2 kilometers of the theoretical perfect center of the L2 well. Each maneuver is more mathematically impossible than the last. In 4 million years of cometary observation, humanity has never documented a celestial body actively steering itself into a stable orbit around a Lagrange point, because 3I Atlas did not just drift into this zone by chance. To understand the gravity of this situation, we must look at the orbital mechanics involved. The L2 point is practically a gravitational pinhead. Hitting it from interstellar space is like firing a rifle from New York and hitting a specific coin in Los Angeles, while accounting for the gravitational pull of the moon. The precision here is remarkable. When you examine the data closely, it feels less like an astronomical anomaly and more like an intentional, calculated arrival. And that is just the beginning, because the real mystery starts now. What fascinates scientists about this data is the sheer silence of the object. It is parked in our backyard, balancing against the gravitational forces of the Earth and the Sun, yet it remains completely dormant across the electromagnetic spectrum. To comprehend the magnitude of 3I Atlas resting at L2, we must look at the mechanics of Lagrange points. L2 is not a physical platform. It is a mathematical equilibrium, an invisible well, where the gravity of the Sun and Earth perfectly balance the centrifugal force of an object. But it is inherently unstable, like a marble resting on a saddle. And then on April 8, 2026, something changed. NASA's instruments detected brand new, impossible data. 3I Atlas began executing micro-oscillations. This was not in the models, it was not predicted, and it changes everything. It was not just sitting there. It was actively maintaining its position against the solar wind and gravitational perturbations without thrusters, without mass ejection, and without a thermal footprint. A missing thermal footprint is completely impossible, but it has been confirmed 3 times. If you could zoom out to the cosmic scale, it looks like a dead rock surfing a gravitational razor's edge, making continuous, flawless corrections. Consider the implications before we speculate and examine the evidence. Let us quantify this precisely. The probability of a rogue comet naturally decelerating by exactly 12.4 kilometers per second without outgassing is practically zero. If we assign that a highly generous 1 in 100,000 chance, and the probability of its trajectory perfectly intersecting the Earth-Sun L2 point, roughly 1 in 2 million, we must multiply those probabilities together. The equation yields a statistical absurdity. That is a 1 in 200 billion chance. That is the equivalent of flipping a coin and having it land on its edge 10,000 times in a row. In 4 million years of cometary observation, we have never seen this combination, so let that sink in. The numbers are completely unambiguous. 33 billion tons of mass are perfectly locked in a halo orbit. The consensus is shifting rapidly. Even top experts at Harvard, who have spent decades studying interstellar objects, have stated that the mechanical precision of 3I Atlas cannot be reconciled with a natural origin. When someone at that level publicly questions the fundamental nature of an object, and when the Jet Propulsion Laboratory takes emergency action to reroute deep space observation time, we need to pay very close attention. At 36 hours before arrival, the rotation of the object was steady. At 24 hours, the spin began to slow. At 12 hours, the object's albedo shifted dramatically. Right now, the clock is running on our understanding of celestial mechanics. Think about it this way. A tumbling comet does not simply stop rotating because angular momentum must be conserved. To halt a spin of that magnitude, you need a counter-torque, meaning you need a directed force. Yet the Hubble Wide Field camera detected absolutely nothing. There is no natural explanation yet. Look at this data point. The object is absorbing solar radiation, but it is not re-emitting it as heat. Where is that energy going? From a thermodynamic perspective, this violates our most basic models. Imagine an ice cube sitting in the blazing sun, but instead of melting, it simply absorbs the heat and remains freezing cold. Now multiply that by an object 14 kilometers wide. In simpler terms, the energy is being stored or utilized internally, not radiated away. The physics here is intriguing because it forces us to discard our textbooks. Everyone assumes a celestial body must obey Kepler's laws passively, but the data suggests otherwise. This object is behaving dynamically. When you examine the data, you see corrections happening every 45 minutes on a rhythmic artificial cycle. The question that keeps scientists thinking is, what is powering these corrections? This defies all our models. But that is just the beginning. The real mystery starts now because 3I Atlas is not alone at the L2 point. We have highly sensitive satellites parked in that exact same gravitational well. We have the Gaia spacecraft mapping the Milky Way, and we have the James Webb Space Telescope peering into the dawn of time. From our vantage point, this appears as an impossible convergence. A dark, massive object has moved into the exact same neighborhood as our most advanced, fragile scientific instruments. The telescopes are pointed and the detectors are live, but the data that prompted an emergency classified briefing at ESA headquarters is truly startling. This is the observation that caused astronomers to stop looking at the deep universe and focus entirely on our own cosmic backyard. We thought the impossible deceleration was the peak of this anomaly, but we were wrong. What comes next is more shocking because this object is not just holding its position. It is doing something far more specific and far more deliberate. When you see the telemetry, it fundamentally changes how you view our place in the cosmos. Hold on, because it gets worse. Everything we have uncovered, including the 3 major anomalies, the 1 in 200 billion impossibility statistic, and the mounting concerns from Harvard and MIT, was thoroughly documented by April 8, 2026, but we are not done. On April 9th, the flight dynamics team at NASA's Goddard Space Flight Center detected something else entirely, something not in any prior data stream, and something that was absolutely not supposed to exist in the orbital mechanics of a comet. The trajectory of 3I Atlas altered by a fraction of a degree in a purely non-gravitational acceleration event, but it was not random. It perfectly matched a station-keeping maneuver executed by the James Webb Space Telescope just 14 minutes prior. Let that sink in. The 33 billion-ton mass is actively mirroring the exact halo orbit of our multi-billion-dollar observatory. When the James Webb Space Telescope fires its thrusters to maintain position at L2, 3i Atlas mimics the precise velocity adjustment. It is flying in formation. Think about that for a moment. The numbers are definitive, showing a synchronized movement within a tiny 0.005% margin of error. Consider the implications. If this is a natural shedding of mass perfectly timed by pure cosmic coincidence, then our understanding of thermodynamic outgassing is completely broken. If this is a gravitational shattering effect, then we have discovered a new physics paradigm involving dark matter interactions and Lagrange points. But here is what keeps astrophysicists awake at night. If this is an artificial object utilizing active propulsion without a thermal signature, then we are dealing with a technology millions of years ahead of our own, currently studying our greatest telescope. Within 4 hours of this telemetry sync, NASA and ESA did something completely unprecedented. They initiated a total communications blackout on the James Webb Space Telescope's non-essential public data feeds and convened an emergency closed-door session at the Jet Propulsion Laboratory in California. In 60 years of modern space exploration, that specific protocol has happened rarely, if ever. That alone tells you the sheer magnitude of what we are dealing with today. When institutions of this caliber pull the plug on public data to analyze an incoming signal, the scientific consensus shifts from curiosity to an absolute defensive posture. Imagine looking at the live telemetry displays and seeing a mountain-sized object purposefully dancing with our most fragile instrument in the freezing dark of space. 3 independent sources validated this mirrored movement, and the mathematics simply cannot be ignored any longer by the mainstream academic community. Look at this data point. The physics here is intriguing because there is no known mechanism for a comet to shadow a satellite, and we are not finished because the data establishes what we know with absolute certainty. First, 3i Atlas perfectly decelerated, bleeding off momentum without any detectable thermal outgassing or mass ejection, which defies standard modeling. Second, the statistical probability of a natural celestial body actively navigating into the Earth-Sun's L2 Lagrange point is less than a 1 in 200 billion chance. Third, the highest authorities at NASA and ESA have independently confirmed these orbital mechanics and subsequently initiated unprecedented data blackouts across multiple international observation networks. Fourth, and most recently, this massive weight is now actively mirroring the exact station-keeping thruster burns of the James Webb Space Telescope with a near-perfect margin of error. These are not theoretical models or mathematical anomalies. These are thoroughly documented, rigorously peer-reviewed physical observations. But one critical question remains unanswered today, an absolute mystery that the official NASA emergency briefings and the ESA classified reports carefully avoid addressing in their public statements. What is powering the non-gravitational acceleration, keeping this object perfectly tethered to our greatest observatory? Because the answer determines absolutely everything about our future place in the universe, we must consider every angle. If this is a radically unknown gravitational shadowing effect, then our entire understanding of celestial mechanics requires a complete foundational rewrite. If this is a dormant, naturally occurring exotic matter fragment, then we have discovered a paradigm-breaking new state of physics right in our cosmic backyard. And if it is artificial, if this large object is utilizing a propulsion system that produces zero thermodynamic waste to actively study our technology, then we are staring at the ultimate revolutionary implication for humanity. There is no middle ground here. One of these 3 scenarios is our absolute reality, and the clock is running right now. As you watch this, the Deep Space Network is collecting continuous telemetry, and every single hour brings unprecedented, impossible new observations. In less than 48 hours, the James Webb Space Telescope is scheduled to execute its next major orbital correction maneuver, and ground-based optical telescopes are precisely pointed to see what happens next. If you want to stay updated on this unfolding cosmic mystery as the data breaks, make sure to subscribe to the channel and turn on notifications so you do not miss our next urgent report.